Thank you so much for coming back today at our channel, The Physics Mindset, the only channel to give you electrical engineering, electronic repairs, and solar installation. Now, today we are going to look at the topic of electrical resistance. We're going to talk about the resistance of the cable. If we talk about, if you see the word electrical, it means we're going to talk about the cables. I mean, the resistance means the resistance in the cable. Okay, this resistance is different from the resistors which are used in an electronic circuit. Okay, also those resistors have resistance, but here we're going to talk about the natural difference, the natural resistance of the cable. Okay, or other people can call it the wires. Each wire, let us say an example of a copper and aluminium. They have resistance in those materials. The materials used have resistance in them, and this resistance is the one which we're going to talk about in electrical resistance. Now, let us first see the definition of electrical resistance so that we can understand the topic. Okay, now here I'm saying electrical resistance is the opposition or the resistance, or to oppose something. Electrical resistance is the opposition that a conductor, listen very well, that a conductor offers to the flow of electric current. That opposition which a conductor offers to the flow of electric current. Check this. If this is the current, let's say this is the current moving in this direction. This is the cable. Okay, now current is moving through the cable. In this cable, let us say it is a copper wire. In this copper wire or a copper cable, it has resistance in it. Every conductor has resistance. Just know that. Whichever conductor, either aluminium, either copper, they have either gold, they have resistance. Now, when the current is passing through, it will face some obstacle. Okay? Which obstacle is the resistance of the cable, the material used. And this is the opposition. Electric resistance, and this is where we find the electric resistance. Remember, electric is the electrons, negative charge, moving. That is electric. Now, this electric current is being opposed by the conductor resistance. Inside the conductor there is resistance, and that's why when the current is moving, it is facing a lot of resistance, though it is passing through this resistance. Okay, current is passing through, but there is resistance inside the cable. Okay, and that's why we came up that electrical resistance is the opposition that a conductor offers to block the flow of electric current, or to oppose the flow of electric current. But this resistance inside, we shall see the factors which bring up this resistance. Okay, now let me give you a simple illustration, just a simple illustration, and I'm just going to explain it. Right, take this as, put it inside you and take it like water flow. Okay, everyone knows water, and everyone knows water flow through the pipes. Okay, now just see this picture. When the water is flowing, when the pipe is narrow and it is too long, water will have difficulties in flowing through the cable, I mean through the pipe, because of the distance. When the pipe is so long and narrow, water will have some difficulties to pass through the pipe. This is the pipe. and water is passing through. Okay, it is narrow. This is water. Water, when it is too long, okay, water will have some difficulties. The starting pressure is not the ending pressure when the water is moving in the pipe. Now these difficulties turn it into, now in electrical, also when current, this is the cable is the pipe, and once the current passes through the cable, when the cable has resistance, current must have some difficulties in its flow through a cable with resistance. And once the current is flowing, resistance is always there. Just not all materials have resistance. All conductive material have resistance, either copper or aluminium. Okay? Now, let me show you something small. And if we understand the resistance, the electrical resistance, if we understand the electrical resistance, it will help us to deal when you are becoming an engineer who can design and size cables. Without knowing this electrical resistance, you will just wire someone's house without minding anything. But once we study about electrical resistance, we shall know that if in any cable there is resistance, and we shall know the materials which have high resistance and low resistance. Okay? Now check. A copper cable, an aluminium cable. Okay? Why do you think that? Why we do our electrical wiring using copper? Why? And why don't we use our electrical wiring using aluminium? Yet aluminium is cheap and copper cables are expensive. But we are using copper cables to do the electrical wiring in our houses. We are not using aluminium cables. Why? It's because of their electrical resistance factor. Okay? Now, this one has copper cable have low resistance, have lower resistance. Okay? And aluminium have moderate resistance. Meaning moderate means it is either high or low. That is moderate resistance of the aluminium. Meaning aluminium, in fact, aluminium has 0.027 ohm per meter squared. This is the resistivity of the material of the aluminium material. Okay? And copper has 0.0172 ohms per meter squared, because the resistivity, this is the resistivity of the material. We are going to talk about it when you reach at the factors which make a cable to have electrical resistance, to limit the flow of current through the cable. Okay? Now, engineers use copper because of this resistivity of the material, because it has low resistance, whereby anything with low resistance, it allows current to pass through smoothly. And a conductor which has high resistance or high resistivity with the material limits or opposes, it limits the flow of resistance. If it has high resistance, meaning the flow of current will be limited in that material or cable. And we shall have difficulties in our lights, in our gadgets to work efficiently, Yet we want our things to work with the proper flow of electrons. Okay? Now, and this is why engineers, electricians who have studied electrical resistance or electrical engineering and properly understand it, once you master the electrical resistance, you will know that you will have a mind in you that I will not just wire people's houses. I will have to calculate the cable needed. Either I'm going to work on a light circuit, that is the circuit which is going to go on the lights, meaning light circuit, what is the millimeters of the cable, the cross-sectional area of the cable. Okay? And that is where, let us say, if it is lighting circuit, we shall use 1 millimeter, or the good one is 1.5. Okay? Now, if it is in the socket or power circuit, those are the circuits which goes in the socket, that is 2.5. Okay? Now, people just know this, that, oh, on lighting circuit, they put 1.5. On the sockets, they put 2.5. On the cooker control unit, they put 4 millimeters. No. It is right, a bit, on top of electrical, that if it is light, it is 1.5 millimeter squared. This is the cable. Okay? That is the cable. But if it is sockets or power, because power, a socket is like a power source, positive, neutral and live. We use 2.5 millimeter cable. Okay? Now, once you know this, and you will know that it is 1.5, 2.5, 4 millimeters, 6 millimeters, or 10 millimeter. Okay? Now, if you don't know the electrical resistance knowledge, you'll have your electrical knowledge will be so much summarized, and you can't talk about these cables. If someone ask you something like, tell me why you're using 1.5, you don't know the electrical resistance. But once you master electrical resistance, you'll be in position to answer such questions. That it depends on the factors, like the resistivity of the copper material, okay? The length of the cable. We're going to look at them in the factors which make a conductor or a cable to have that resistance, the electrical resistance, which is the opposition that a conductor offers to the flow of electric current. The opposition, the current is passing, but there is an opposition. Even though the opposition is there, still current penetrates. Current passes, because current has a force which is pushing. This force is the voltage. The voltage is pushing the current, and a current is penetrating through the cable resistance. And this is the electrical resistance we are talking about. Okay? And that's why a lot of engineers, they do and calculate, they carefully select a proper cable size for any circuit. If you're a true engineer, true electrician, technician, okay, just know that if you carefully select the cable sizes, don't just wire because you know cables, that this is 2.5. If 2.5 I put it on a lighting circuit, it will work. Yes, still it will work. But you know that your bulb will blow. Why? The logic is here. When a cable, this is the cable. Okay, let me use this. Sorry. Now let me give you something small, which all you guys, you need to have in mind. Okay? Because today we are talking about electrical resistance. Electrical resistance, don't just go and wire. I told you this channel is much technical, and our aim is to deliver the technical knowledge to you if you are watching, so that you know what you will be doing tomorrow. Okay? With an experience. Now, I'm going to tell you something. People know that 1.5 millimeter cable, squared cable, is for lighting system, lighting circuit. Okay? And they know that 2.5 millimeter squared cable is for sockets or power. Okay? Now, let us give an example on these ones. Don't come and you put a 2.5 millimeter cable on light circuit. Okay? That is wiring in the main switch. I'm giving you how a circuit moves. From the main switch, that is where it starts from. You connect the circuit breaker. Connect the circuit breaker. From the circuit breaker to the switch, that is the light circuit. From the circuit breaker in the main switch to the switch in your house, which is near the door, or as the switches are being installed near the door. Now, from the switch, it goes to the light or to the lamp. Then from the lamp, it goes back to the main switch. That is a circuit. The one which goes back to the main switch is the neutral. A neutral comes from the main switch direct to the bulb. Now, let us see what I'm talking about. This is the main switch. Okay? Main switch. Now, there is circuit breakers inside the main switch. You select one. You calculate the current. Remember, you can put from 5 amps to 15 amps. That is for lighting circuit. You're wiring in the house. You have used, let's say, 10 amps for light. From the light, that is live part. Remember, in the main switch there is 2 cables, live and neutral. Okay? Now this is the neutral. The live goes direct to the switch near the door. This is the switch. Okay? From the switch, it goes to the light, to the bulb. This is the bulb. Overhead lamp. Okay? Now, from another terminal of the bulb goes direct to the neutral. This is the neutral. This is live. And this is a circuit. Okay? Just know the circuit is done. Live moves through the switch, then it goes through the bulb, then it goes back to the neutral. And that is the complete light circuit. You have used 1.5 millimeter cable. Okay? And this wiring, the bulb will work. If you switch off, a switch is just a cable, like this is the cable. If you get your plier and you cut the cable, that is a switch. You have created a switch. And if you connect these wires again, meaning you have switched on. And instead of doing this, removing the cable and connecting them, instead of connecting back again the cables, they decided to introduce a switch. And from the switch, the bulb. From the bulb to the neutral. You're using 1.5. That is the best wiring. Always. Technicians, electricians use that. Here comes someone who heard about that. He knows the flow of current. The live goes to the switch, to the bulb, then to the neutral. Then he gets his 2.5 millimeter cable. And he uses on the lighting circuit. Now, what happens? After 2 months, the bulb will blow. He buys another bulb. After another 5 months, the bulb will blow. He buys another bulb. You see how you're spending money on this circuit. But the problem is you used the wrong cable sizing. I know we shall go there on the cable sizing, but I need to show you because we are talking about the electrical resistance. Because now the logic is here. This is the cable. Not, just be serious here. This is the cable. If it is small in size, okay, electrons will fidget to pass through a cable when it is small. Okay, when it is going to reach the bulb, there will be hard flow of electrons, and in this interval of electrons, this is the voltage or electrons moving. In this interval of electron moving through the circuit to the bulb, because they are fighting to reach and the cable is small, that is 1.5, the bulb will light. Okay, because you have used a cable which is allowing electrons to come at the bulb. There is some calculations on why it is 1.5, and we shall look at them. Or why do we use 2.5 and why do we use the amps? Their calculations on cable sizing. Now this light will light up because of the electrons moving, squeezing themselves, fighting. Another scenario, when you use 2.5 on the bulb, 2.5 is bigger. Okay, now this is the bulb here. 2.5, this is our cable. Electrons will have more space when they are flowing in 2.5 cable, when you're using a 2.5 in the lighting bulb, and they will come in big volume to the bulb. That's why our bulb blows, because of high current. When the cable is big, it has space and the resistance will be low, because electrons will have space to flow in the cable. And once the electrons flow when they are in big volume, they can reach the bulb and they make the bulb to blow. Once the bulb holds a big quantity of electron moving, once the electrons are in big quantity, the bulb may fail to control and eventually it blows. That is the logic behind. Because this 2.5 cable is not meant for the lighting circuit, because it allows more electrons, and when electrons have space to move, there is less resistance than when the wire is small, 2.5 millimeter. Okay, the electrons will fight. They reach at the bulb when that is the real electrons we want to light the bulb. Now here, if you use 2.5, let us say 4 millimeter, the bulb may blow, the bulb may not blow, but with the time it will blow because of a wrong cable sizing. Okay, now let me show you the factors which are affecting the electrical resistance. Why a cable has electrical resistance? Check these factors. Okay, now let us see the factors which brings the cable to have electrical resistance, which brings a cable to have resistance in the flow of current. Okay, what are the factors? Let us say factors which led cables to have electrical resistance. Okay, what are the factors which make a cable to have electrical resistance? Or in a simple term, the factors which make the cable to limit the flow of current. And this is why engineers are best to select a proper cable sizing when they are doing their electrical wirings. Okay, don't just bring any wire to wire the circuits. You must know the lighting circuit, you must know the power circuit, you must know the cooker circuit, okay, cooker control units. You must know the supply cable. Don't just bring and you wire, even though you have the knowledge that live passes here, neutral passes here. You need to know the proper cable sizing. But without knowing the electrical resistance, you will not know why we select 1.5 for the socket, for the light, 2.5 for the sockets. All the logic behind that starts with the electrical resistance. Now, what are these factors? Now, the factors, one is the length of the cable. Length of the cable causes an electrical cable to have electrical resistance. Here comes, it is self-explanatory, like a longer cable. When the cable, let us say, we are going to power a motor which is in the distance of 150 meters, or let us say 200 meters. 200 meters. The source is here. Source of power. Source of power is here. Okay? The distance, this is our motor. Either in a workshop, a carpentry workshop, okay, or a factory, a motor is going to work to produce some products. Now, this is our source of power. The distance is, let us say, we said 150 meters or 200. Let us take 150 meters. Now, you power here. This distance is too long for this machine. They use motors. For this machine to work efficiently because of the length of the cable. This is one of the factors, the length of the cable. And this cable, in its material, let us say a copper, it has resistance in it. And with this resistance, the amount of current from this point is not the current we shall get here. Okay? Because of the resistance, the current will move for longer distance, for 150 meters. And reaching in the motor, the current will be weak. And even the voltage which is pushing the current will be weak. And the motor will not work the way we want it. Okay? Because of the length of the cable. And remember, the cable has resistance in it. This resistance is limiting the flow of current. Now, the moment the current reaches travel for 150 meters, it will be weak. Let us say, for example, for the lights. Hope people have ever wired some let us say security lights. If this is your bulb, the first, and this is your supply, okay, voltage or current, one bulb, second bulb, third bulb, in series. Okay? In series we said this is one bulb, this is bulb 1, bulb 2, bulb 3, bulb 4. Okay? In series we said the voltage increases but current remain constant. And the moment if this bulb will be bright but this one will be dim. Why? Because of the longer distance. The current will reach this bulb, the last bulb, when it is weak. And this is applied here. When the voltage reaches the motor will not move the way we want it. And this electrical resistance in the cable will limit the flow of current. Sometimes in their limitation, if you use a small cable, because some people may say, let us use small cable so that we don't waste too much power, so that power reaches the motor. The moment you use small cable, as I have explained to you, small cables, the electrons will fight. This is the cable. Small cables, electrons will fight to pass. And this interval of fighting, you will feel heat of the cable. The cable will heat up. Once the cable heats up, that is what we call voltage drop. Okay? That is what they call, there is some voltage drop. Once you hear the volt, now you touch this cable when it is, let us say, it is 1.5 millimeter. The cable will heat up, and that heat means we are losing the voltages. The electrical power is being, or electrical energy is being transferred into heat energy, which heat energy we are not using it. You see how we are losing our voltage drops. The moment it reaches the motor will fail to run because all the voltages are being wasted, all current are being wasted. Instead, a wise electrician will use the big cable. Let us say you might even use 10 millimeter cable. Very big like this. Electrons, remember, when electrons have space to move, meaning there will be less resistance. And here electrons will move freely. And the moment they reach the motor will run the way we want it, because we have used a 10 millimeter from the source of power, which is the voltage or current. And we have used a big cable. Now the motor is running and efficiently producing our products which we want in a factory or a workshop, than when you use a small cable. Okay, here there is space and electrons are moving freely. Remember, electrical resistance is an opposition to the flow of current. Now, once current is moving freely in the big cable, resistance is less. And these electrons, once they are moving freely, they are not fighting to create heat in the cable. We shall have our motor running. And this is the problem of the length of the cable. Okay? The length of the cable creates high resistance. And once you use a small cable size, it also does what? Create high resistance in the cable. Another point is 2. What can we say on 2? You see the cables, they have what we call the cross-sectional area. Now, a cable has what we call the cross-sectional area. And this cross-sectional area determines the electrical resistance. Check. Similar to what I've explained. When a cable, this is the cable, okay? This is our cable, 1.5 millimeter squared. It's the cross-sectional area. What they mean by the cross-sectional area is, this is the copper cable. Once you have removed the insulators, okay, or the insulation, you remain with the copper. Okay, now here on this starting part is the cross-sectional area. Okay, this is the cross-sectional area we are talking about. Now, if it is a 4 millimeter, this is the copper. Remove the insulation. The cross-sectional area is this. Okay, the beginning part, the size of the cable is the cross-sectional area. Now, if the cross-sectional area is small, electrons are coming much, they will find where they are passing, the size is small. Now they will fight to enter this cable of 1.5. Let us say you have used a 10 millimeter to connect with a 1.5 millimeter. 10 millimeter will carry much electrons or much current. That's why if someone connects a 10 millimeter with a 1.5, he's not an electrician. He's just forging things. And yet I told you we don't forge, we don't guess in electrical. We do what we know. Without knowing electrical resistance, you will not understand the principles here. Someone will connect a 4 millimeter and he connects it with a 1.5 millimeter. The reason is because he didn't study or he has no knowledge on electrical resistance. This one is bringing a lot of current because the cable is big, and this current must pass through the 1.5. In passing through the 1.5, they will fight. In the interval of fighting, this cable 1.5 will heat up. It will heat up the cable, and once the cable heats up, that's where you see insulation moving on or melting. Okay, and once the melting happens, what happens? That's why you hear house getting burnt, and we see people saying, that house has got burnt because of electricity. Someone can ask, how? Because of the unprofessional electrician who are connecting a big cable mixed with small cables. Okay, only this thing is done when you connect a circuit breaker which controls the flow of electrons or the flow of currents. Don't just connect your 4.5 with a 1.5 and the bulb will work and you say, yeah, you're a good electrician or a technician or an engineer. That is the wrong thing. You are burning people's house anytime. 1 year, 2 years, 5 years, the house will get burned because the cable will start heating up. And once they heat up, meaning the voltage is being dropped. And once the voltage is being dropped, the insulation on the cable will melt off. And once the insulation melts off, meaning live and neutral will connect. And once live and neutral connects, that is a spark. And once the spark comes, that is a fire. Once fire comes, the house on fire. That is the principle why the houses get burnt, because of poor cable sizing or unprofessional cable sizing. Okay, that is the problem of the cross-sectional area. Once the cross-sectional area is small, heat will heat up because of electrons fighting to pass through. But once the cross-sectional area is big, or you have selected the proper cable size, the electrons will move freely, efficiently, without any problem, and the cable will not heat up. Meaning the cross-sectional area determines the electrical resistance. Okay, now what else? The third one, we have what we call the cable material. Let us call it material of the cable. We are seeing the factors which lead the cable to have this electrical resistance, those resistance why the cable limits the flow of current. What brings up with this? We say the length of the cable, the cross-sectional area. Now, the material of the cable, either copper or aluminium. Each material has resistivity. We call it resistivity technically. Okay, copper has its resistivity as a material, and aluminium has resistivity as a material. As I told you, copper has resistivity of 0.0172 ohm meter, and aluminium has 0.0272 ohms, because we are talking about resistance in the cable, not resistance in electronic circuits, and this is measured in ohm meter. Okay, now material of the copper has resistance. Okay, now check with this resistance, the flow of current will be limited. Electrical resistance, the material of the copper has some resistance. Okay, someone can say 0.1, this is 0.2. Now, which is having high resistance in ohm meter? Which is having high resistance? It is aluminium, has slightly high, it's moderate, and copper a bit low. That's why we use copper in wiring our houses, because of this low resistance. Because once you know the property of the resistivity of the cable, you will know why we use copper wires. It's not that because it is good, fine, it is efficient. Because of its low resistance, it doesn't heat up. And once the cable heats up, as I told you, it is changing the electrical energy into heat energy. Yet we are just wiring our houses, and once heat is created in the cable, meaning we are having some voltage drops, and yet we are not using that heat. We only want the electrons to reach our bulbs so that they light up, to reach our TVs, our fans, refrigerators, so that they operate. Okay, now copper is considered the best in wiring because of its low resistance than aluminium. The fourth, and that principle, the resistivity, is one of the factors why cables have resistance in them. Now the fourth one, the last one, I will call it temperature. Here some cables, once a cable heats up, this is the cable, current is passing through, this is current, you have done your wiring, current is passing through. Okay, once the cable is small, let us say when it has the cross-section area is small, the cross-section area, it is where you people call, like, a cable is 1.5 millimeters squared, that is, this cable 2.5 millimeter, because the cross-sectional area is measured in meters squared. That's why we have 1.5 millimeter squared, 2.5 millimeter squared. And that's why once we have the cross-sectional area and the temperature, I'm explaining the temperature. Once the cable passes through current, cable mate, let's say if you connect very many loads on this circuit, in the socket, the cables inside your wiring may heat up. And once they heat up, that is, the temperature increase. Once the temperature increases, once the heat increases, the resistivity inside here, we have resistance. Now we have another thing, another element, which is heat. And once the electrons continue to move, when there is heat and there is also resistance, don't you see? Heat and resistance, two things now are available, meaning the flow of current will be hard. Voltage drop is there because of the heat created, which we are not using it. We are okay. Once the heat comes, once the heat increases, also resistance increases. And these are the factors which brings or which make a conductor or electrical cable to have resistance in it. Okay? Okay, now let us try to see the formula. Okay? Because electrician, I know engineers, they like calculating. Physicists, we like calculating. We like the formulas, to know the formula of calculating something. Whereby I can't leave you without giving you the formula. So that anything you can make a formula. Student can ask you something about this topic of electrical resistance. Let me rub off this. I'm going to give you a formula of calculating electrical resistance. The formula to use to calculate the electrical resistance, we say electrical resistance, which is R, is equals to rho times the length of the cable divided by the cross area, the cross-sectional area. This is the formula you use, and it is measured in ohms meter squared. This is the formula you will always use when you're calculating electrical resistance. Okay? It is different with resistance, the formula used in resistance when you're calculating the resistors in electronic circuits. This is electrical resistance in the cable. Whereby, let me write in full, whereby R will be the electrical resistance. Rho, which is written by rho, is the resistivity of the cable material. Resistivity of the cable material, and is measured in ohms because it's resistance. Now L is the length of the cable measured in meters. Okay. A will represent the cross-sectional area of the cable. The cross-sectional area measured in meters squared. Okay? Yeah, that is the proper formula we can use to calculate the electrical resistance. If they ask you the cross-sectional area, if they give you the length and they give you the resistivity, okay, length of the cable, let us say it is 100 meters, a roll of 2.5. 2.5 is the cross-sectional area, the length is 100 meters, the resistivity, they will give you the figure. And if they say calculate the electrical resistance, you use the formula. Measured it in ohms. Okay? Okay, now we're going to look at why we need to know electrical resistance. Why you are supposed to know electrical resistance as a technician or as an electrician. Okay? Without knowing this, there are a lot of things you will miss when you're doing your electrical engineering or your electrical installations. The reason why we need to know the cable resistance, why we need this knowledge of electrical cable resistance. Once you know why cable have resistance, you will know the voltage drop along the cable. You will know the voltage drop along the cable. Okay? When cable heats up, or when the length of the cable is long, there will be a lot of voltage drops. And once you use a small cable, meaning you will have some voltage drops, and where you are taking your voltage, if it is a long distance, you will have less voltage at the end where you're taking your cable, your voltages. Okay, now once you use a big cable, meaning if you're using a long distance, you're going to use a long distance, use big sizes, big millimeters, to carry your cable in big quantity. Okay, now without knowing electrical resistance, you will not have this knowledge that there is a voltage drops. But once we have the electrical resistance knowledge, we know now that we shall have some voltage drops if we are transferring our electricals or our voltages from one place to another in a long distance. 2. Once we know the electrical resistance, we shall know that there will be power losses. Okay? You can't have this knowledge of there is power losses in the cable in form of heat in the cable. Without knowing electrical resistance knowledge, you will know that there is a power loss in a cable. Some people just know if they wire a house, okay, and the house start working, they don't know that there is power losses in the cables. Okay, whereby if you use a small cable and you're going to power your cooker control unit, the cooker will pull a lot of current from the main switch. Okay, now from the main switch, if you have used the 1.5 to power your cooker control unit where you cook from, that coil which is rated like 1500 and above watts, it will pull a lot of current so that it lights up and it cooks your food. Now if it finds a small cable size, if you use a 1.5 millimeter, the cable will start heating up, and once the heat comes, meaning we shall have some voltage drops, because this heat we don't need it in our cable, and the current will be moving too much, and your meter which counts your units, you will have a lot of units because of the heat which is being used which is created in the cable. You see, without having the knowledge of electrical resistance, you can't have that. If we know the knowledge of electrical resistance, why we know the cable resistance, it helps us to reduce the efficiency of electrical system. I mean, it shows that if electrical resistance, if the cable has resistance, if there is high resistance in the cable, it reduced the efficiency of the electrical system. As I explained to you, that a motor will not run well when you have used a small cable, when the distance is very far. Let's say a motor is in 200 meters and you have used a 1.5 meter. When the power reaches the motor, it will be less the power we wanted, or current we wanted, or the voltages we wanted, and the motor will not run at its efficient rate. Okay, meaning there will be a reduced efficiency, and it will call us that we need to install with using a big cable sizing to transfer power to the motor because of a long distance. Without knowing electrical resistance, you will not have this knowledge that there is reduced efficient. Someone may end up saying that the motor is not working, yet you just don't know why you have used the cable. The cable sizing is small. Just change the cable and put a big one. You will see the motor working. The motor will be okay. But once you don't have this knowledge, you'll think that the cable, you'll think that the motor is not working. Now, and once we know the cable resistance, we shall know that there will be overheating of the cable. The cable will heat up. when we use a small cable and we are going to install in our cooking or on our cooker, this cable will heat up. And once the cable heats up, it will damage the insulation. Overheating, which can damage the insulation. The insulation, these are the covering of the cable. And once the cable, the copper wire heats up, it will heat the insulation on the cable. And once the insulation on the cable heats up, the cable, a neutral and live, can come into contact. And once they come into contact, that is a spark. They don't deal. Live doesn't like neutral. Once they come together, that is fire. That's why I say electrical is fire without smoke. Though people say you can't find fire without smoke, but in electrical, it is there. Put neutral and live together, you will see that there is fire without smoke. And this is the information about electrical resistance, whereby we all need to know, we all need to have this as electricians, technicians, and engineers. Students who are studying electrical engineering, you are very welcome if you have this knowledge of electrical resistance. We are still on the fundamentals. We are soon finishing the fundamentals of electrical. And once we start the generation, I think you will be having a lot of information about electrical fundamentals, where electrical started. All this I'm showing you, the terms to be used in electricity or electrical installation or electrical engineering principle or course, okay? The fundamentals, how to take care of electricity, what happens in a cable, what is the cable, how you can use the cables, so that when we start a generation, we know what we are going to talk about, okay? And this is the information, and I will appreciate if you thumb on the notification bell, and if you share the video to your fellow students, family members, your friends. They also need the information to know about electrical resistance, okay? Share, like, subscribe. Share the channel so that the knowledge goes far in the world. Thank you for watching. See you in the next topic, which is going to be about the electrical voltage. You can't miss this. It will be, we are following from resistance. Now we are going into electrical voltage. Remember the other time we saw the electrical current. Now why don't you learn about electrical voltage? We shall see notes about electrical voltage so that you know, oh, this is what, if you hear anything about electrical voltage, you know what to do. Now I think you know what to do if you hear about electrical resistance in the cable. We shall also see electronic resistance, whereby we shall talk about the resistors, okay? They are different, electrical resistance and electronic resistors. They are two different things. Thank you for watching. See you in the voltage, in the check.